Saxon Advanced Mathematics, lesson 51. We're going to talk about logarithms, common logarithms, and natural logarithms. What does that even mean? Well, I'm going to explain it all to you. This is going to be calculator-driven work, so grab your calculator, and I'm going to introduce you to the buttons before we dive into the problems. So, pause me and get your calculator if you don't have it with you already. Okay, first I want to review terminology. The word exponent and the word logarithm have the same value, okay? They're interchangeable for the most part. Sometimes we use one or the other. I tend to use this one because it is more familiar to you and it helps you gain traction with the problem. The same for these two numbers. The number is sometimes called the anti-log, all right? So I tend to use these numbers, but these numbers make sense too. I'm not gonna over focus on this, but just know that I'm using this set of terms rather than the true log terms because they just throw smoke on the fire. I don't know if that's right, but anyway. These are the 4 buttons that will show up on your calculator. And I bet you dollars to donuts that they're arranged in this order. And so we're going to talk about what they mean and when you use each one. Those two are usually in the top row, in that order. And then down here, this is an L. It's a lowercase l. It stands for natural log. I write it in cursive so that it doesn't look like a 1. Right? There are the 4 buttons. The first thing I want to point out to you is that these 2 buttons work in what we call the base of E. E is what we call the natural log. It is it's a number that appears often in nature and in engineering, so the sciences use it quite a bit. It also shows up in statistics. E is a number, kind of like pi, where we use a letter to represent it because it's long and indefinite. It's approximately equal to 2.718, and it goes on from there, okay? That's the one that usually skeezes students out a little bit. It just feels weird. What's more comfortable is this other set of buttons because they relate to base 10. Base 10 is not only how we've always learned to count, but it's also how we're built because we have 10 fingers and 10 toes. So we're kind of naturally acclimated to base 10, and we often call that the common log, okay? So you can see these 2 columns. This first column represents base E. This second column represents base 10. That's fairly easy to keep straight. Base E is referred to as natural. Base 10 is referred to as common. There's the value of E so that you know it's not just some weird letter. It actually represents a number. Now, what's the difference between this row of buttons and this row of buttons? I will tell you. This row of buttons is what we use when we have the exponent and we want the number. Okay? Notice that the x is in the exponent. So if we know what the exponent is, we can plug it in depending on which base we want, and then that will give us the calculation. So for example, if we put a 3 up here, the answer would be 1,000. Right? Because 10 to the 3rd power is 1,000. So we knew the exponent, we wanted to know the number. This row is for when we have the number and we want the exponent. Okay? So let's say that, and we're going to do this, let's just do the first problem because it's a great example of it. 51.1. It says write 2.4 as a power, meaning write it as a base. Oh, here's the piece we're missing. Okay, so 2.4 is a number. We want to write it though with either a base of 10 or a base of e. We need to know what exponent you would put on the 10 or you would put on the e in order to reflect the original number of 2.4. So this is a case of this second row of buttons. We have the number, we know we want 2.4 to be the number, but we want to know what exponent or power we would put on 10 or on e in order to calculate that. And that's exactly, these are the two buttons that we'll use. So let's start with the base of 10. What we'll do is I want you to enter 2.4 into your calculator, then hit this button, log 10. The answer that you'll get is 0.38. Okay? What that tells you is that, I'm trying to think of where to write it because I'm running out of space, is that 2.4 equals 10 to the 0.38. Oh my gosh, you cannot see that. I'll scoot it up though. 2.4 equals 10 to the 0.38. This is the exponent. We use this button because we have the number, 2.4 is the number, and we wanted the exponent to go on base 10. So that's what we got, 0.38, and we can write 2.4 equals 10 to the 0.38. Now we'll do the same thing, only instead of using the base of 10, we want to find what exponent we put on the base of e. So we do the same thing. We take 2.4, enter that, then we enter, and this is very confusing because why doesn't this button look like that button? It's confusing. It's needlessly confusing. They do the same thing, just like these do the same thing. These buttons seem easier to use because it's like, oh yeah, this is the exponent on e, this is the exponent on 10. These don't look the same. It's confusing. But you hit the natural log button, right? Because we want to find the base on e, and the answer that you get is 0.88. What that means is that 2.4 is equal to e raised to the 0.88 power. This is the true answer to the problem. This is the true answer to the problem. This is me helping you understand what exactly it means. All right? This is very important because it is very difficult to understand how these buttons work and which one is which. Notice that in explaining to you how to use the buttons, I have used this language, right? Exponents and numbers, exponents and numbers. I could have talked about logs and anti-logs, but I don't want to make your head spin. I want to ground my instruction around these buttons in language that you're more familiar with, but I want you to recognize that these words mean the very same thing. So we could say, oh, we have the anti-log and we want the log. We have the log and we want the anti-log. Do you see how that just sounds ridiculous and confusing? This chart, all this information right here is super important and valuable. So please copy it into the sacred vault of where you keep important information, whatever that might be. Okay, so we're going to continue to use this to solve a few more problems. There are 5 in all, but they're quite short. Carrying on. It's kind of refreshing. Some of our lessons have those problems that go on for a week, right? And this is not one of them. These are short, simple little problems. We're just learning how to manipulate these buttons. 51.2, find A, the log of 2.4. Now, how do we know what this even means? Well, this is the same problem we just did. Oh, I see what I did. I accidentally did this problem last time. What I did before was kind of a mix-up of 1 and 2. Okay, well, let's just do 2 again. Find the log of 2.4, and B, find the natural log of 2.4. Okay, again, this tells us this is the number, and we want it says find the log. This means we know we want the base 10. This is the number because we know that. Right? What we've got here is this. This is what helps me if I ever get turned around in log problems. I want to show you how to do this. Write down a log that is simple that you understand. In base 10, if you put 3 on the base of 10, you get 1,000. So what we're saying here is, what is the exponent? We know there's an invisible 10 here. We know there's an e there. What do you put on 10 to get 2.4? And we just did that, and the answer we got was 0.38. Okay, and then using the same buttons, this one, only the natural log, because this is the base of e, we enter 2.4 and we hit the natural log button, and we get 0.88. Okay? If that seemed like the same problem twice, I agree with you. That was confusing. Okay, now we want to write the number. John asks us to write 24,000 as a power with a base of 10. Okay, so what we know is that this is the number, and we're looking for the exponent. All right, so going to our chart, when you know the number and you want the exponent, then you're using one of these keys. It's just a question of, do we want the base of e or the base of 10? Power of 10. So that tells us to use this button. So we enter 24,000. That means it's a button on your calculator. And then we hit the log 10. And what that gives us is an answer of 4.38. So if we want to express this big number as a power of 10, we would write it as 10 to the 4.38. Cool, right? The next problem says, okay, take the same number, but this time express it as a power of e. So we do the same thing. We start with the 24,000, but this time we choose the counterpart to that log 10 button. We choose the natural log. We still have the number, and we're looking for the exponent to put on top of it, but we want to do it with a different base. So this time we use the ln button, and we will get as our answer 10.09. What that tells us is that e to the 10.09 is equal to 2,400. Now, if you want to check this, you can easily check your work because now we know the exponents. So if you take 4.38 and enter 4.38, then hit this button, you should get 24,000 back. And if you take this number, 10.09, enter that, and then hit this button, you should get 24,000 back. So these buttons kind of chase each other in circles, which is, I guess, a fun thing. I'm not sure. 51.5 is our last problem. And John cheats and shoves 2 problems into one. He's like that sometimes, boy. Right. Here's the number, 0.0024. He wants to write it it says 10 raised to a power. Sometimes the words are just so confusing. And what we have to do is take what sounds complicated and make it easier. So what he's saying is 0.0024 is the number, and he wants us to find the exponent that you'd put on either 10 or e to get that number. So we do the same thing that we've been doing. For the first one, we would take 0.0024, enter that, and then because it's 10 raised to a power, we use the log 10 button. And the number that you get is negative 2.62. Now this negative makes sense because we have a number that's less than 1, right? So that's okay. What this tells us is that 10 to the minus 2.62 is the way that we express this number in base 10. Again, if you want to check it, you can use the other set of buttons, this one, enter minus 2.62, and then hit that button, and you should get this back. All right? Now we do the same thing, but now we want to find this itty bitty little number, not as a power of 10, but as a power of e. So instead of hitting the base 10 button, we'll hit the very weird looking but equivalent natural log button, and that will give us minus 6.03. And so we can write that 0.0024 equals e to the minus 6.03. And again, these are all right. You can check this by entering minus 6.03 on your calculator and then hitting this button. You should get 0.004 back. All right, so that's the end of this lesson. It is familiarizing ourselves with how to use these buttons, use these calculator functions, and a reminder, this is all you need to know how to do that. Remember that terminology, we can simplify or complicate, but these things mean the exact same thing. So don't let these loggy words freak you out. Okay, 51 is done. Good riddance. 52 is not like this at all, so change of gears. Goodbye.